Namaskar. Welcome to day 2 session 1. Today we have eminent speaker Dr. Agamutu. He is a senior professor with 49 years of experience in waste management in the Jeffrey Center on Sustainable Development at Sunway University. He is the global top 2% scientist in the environmental science by Stanford University. He was also the associate dean at the School of Interdisciplinary Science, Sunway University. He is a fellow of Academy of Science, Malaysia since 2014. He is appointed as the high-level foreign expert for the Ministry of Science and Technology, China. And he is also the visiting professor of Zhejiang University of Technology, Hangzhou, China. He is the chairman of the International Consultant Committee on Waste to Energy, based in Zhejiang University. He was an associate editor in the Chief of Waste Management and Research for 20 years and is currently an international advisory board member for waste management and research. He is on the editorial board of several journals such as Journal of Material Science and Waste Management and Journal of Safety and Environment. He is the vice president of the Society of Solid Waste Management Expert in Asia and Pacific Island. He is the founder, head of the Center for Research in Waste Management and the founder president of the Malaysia Society of Waste Management and Environment. Currently, he is the chairman for the Organization for Climate Change, Malaysia. He is an honorary life member of International Solid Waste Association, that is ISWA. He has published 22 books, 34 chapters in the books, and authored over 480 peer-reviewed articles, proceedings, and invited paper. He has done over 75 consultancy projects and supervised over 200 master degree students and 45 doctoral students. His research interests include solid waste management, plastic and microplastic, marine debris, landfill and biomass, waste to energy, ESG, to name a few. He has international networking and collaboration in several countries such as UK, China, Australia, Japan, Korea, India, Norway, Finland, Cambodia, Thailand, Myanmar, Sri Lanka, to name of a few. With this introduction, I request Professor Agamutu to deliver a talk on sustainable waste to wealth, options and challenging. Now it's over to you, sir.
Thank you very much. Thank you for the comprehensive introduction. I didn't expect you to use the whole bio. Okay, thank you very much. And good evening to everybody. My time here in Malaysia is 9 p.m. And I would like to share a little bit of my information on sustainable waste to wealth, options and challenges. This is an exciting topic simply because people don't use the word waste anymore, because it is an excellent resource if it is properly utilized or recycled. And of course, now people are talking about the 3R, zero waste technology, and EPR and ESG. So with all these mechanisms in place, we do have various options. But on the other hand, we also have challenges in implementing these options. And so in my presentation, I would like to look at part one as a little bit of background to the waste. So how much of waste is generated, and that country and which country generates the waste and so on. Of course, you can always have a discussion later if you need any other information. And the second part, I will talk about what are the options we have to converting the materials or the resources into wealth. Okay. So this is, of course, not an exhaustive topic, and of course, there may be many more that can be added as we go along. I'm attached to the Jeffrey Sachs Center on Sustainable Development within the Sunway University, Malaysia. And if you want to contact me, please use the official email, which is the Sunway email. Okay. Now, first of all, a little background to waste to worth or waste to wealth. Fossil fuel prices have surged 40% in the past decade. And I think everybody knows that, how the fuel price is going up for the petrol and diesel and so on. And so we have an important resource, that is the waste, which can be also utilized as a fuel. And on the other hand, we look at agriculture, which generates about 1 trillion tons of waste annually. And this contributes to about 17 trillion biomass economy globally. So the potential is there. So we have 1 trillion waste and 17 trillion US dollar biomass economy sitting there. Unfortunately, 10% of the global greenhouse gas emissions come from improper waste management, with 80% of the untreated waste harming the ecosystem. And I think people working on the waste, you know that almost 70 to 80% of the waste is actually discarded into landfills, which are not even considered landfill, or it is a dumping ground in many countries, particularly in developing countries. This is the norm. And that is why we have a very serious consequence of a greenhouse gas emission. Something that is relatively new, that is a circular economy, could cut waste by 45% by 2050. And we may be saving about 1 trillion annually in terms of the wastage going to the landfill. And 60 to 70% of waste can be diverted from landfills through waste to energy and recycling. I think many developing countries are already facing this problem of waste being dumped and not being properly managed. Now, where does the waste come from? This is the global waste generation scenario. And I'm giving here for certain sectors, like, for example, the first one is the Middle East. And then we have Sub-Saharan Africa and Latin America and Caribbean, North America, South Asia, Europe and Central Asia, and East Asia and Pacific. Now, if you look at the data, the blue one is for 2016, and then the yellow one in the middle is 2030, and then the orange one is for 2050. Now, you can see that none of the continents or the countries actually shows any decrease in the waste generation quantum. So if you take, for example, the last one, East Asia and Pacific, you can see how it is increasing from 468 million tons to 600 million tons to 740 million tons. So this is the kind of scenario we are seeing. Now, so you may be wondering, does any country actually has achieved the target of no waste generation or no increase in waste generation? Yes. For example, in Japan, it is already declining. So they already achieved a decline in the amount of per capita generation, as well as the total waste is already going down. And similar scenario is also seen in Denmark and in Korea. So we do have selected few countries which actually shows the waste generation going either steady or is going down, but all other countries is actually going up. So if you look at another scenario, this is a regional waste generation scenario, and it is for annual waste generation. Again, you look at the East Asia and the Pacific, which is about 468 million tons. And then we have Europe and Central Asia, and South Asia, North America, Latin America, Sub-Saharan Africa, and then we have Middle East and North Africa. So this gives the amount of waste that is generated annually for the time being. Now that is for waste generation. How is the waste managed? If you look at this diagram, on the left you have the municipal solid waste. You may also have a healthcare waste, construction and demolition waste. Used tire in many countries is becoming a problem. E-waste is also becoming a problem, and used batteries and other hazardous waste. Now, of course, these are on the right side is the hazardous material like tires, e-waste, and batteries, and healthcare waste. It's all hazardous material. Even in municipal solid waste, we have about 1 to 2% hazardous material. So that also causes a problem because in many countries, the waste separation is almost zero, including Malaysia. And this little fraction, 1 or 2% of the hazardous waste that has not been removed from the municipal solid waste causes so much problem for the waste management. For example, if you want to, we have about 50% food waste like most developing countries, but we can't actually suggest composting or anaerobic digestion because of the presence of the 2% hazardous waste. And that is why now there is a serious effort to actually collect the household hazardous waste on a separate day, maybe once or twice a month, to at least make the municipal solid waste more compatible for biological treatment. Now, what is happening with all the waste is that it's going to open burning in developing countries, and that is the norm. And then we have, in some countries, including India, we have informal recyclers, like in Thailand, Myanmar, in Indonesia, so on. But you see, I'm mentioning all the developing countries because informal recyclers are normally not found in developed nations. So we have informal recyclers. They have a very important role, provided the government actually seriously looks at their welfare and formalize these informal recyclers to a certain extent, like what they've done in Indonesia and in Thailand. And then, of course, the other consequence of this open dumping is the disease vectors and spread of infectious diseases and pathogens, and also marine litter. Now, when we talk about marine litter, the first thing that comes to my mind is microplastic, because this has become a serious issue, and one of my main research now is on microplastic in surface water and marine debris. So we are actually looking at the transfer of plastics from one country to another using satellite-based floating bottles that we have developed with the UK assistance. And of course, the water pollution, soil pollution, air pollution is part and parcel of this waste management. And of course, most importantly, it also contributes to global warming. So in low-income countries, over 90% of waste is mismanaged if you include the disposal into dump sites as well as the disposal into monsoon drains and roadsides and so on. So we have a serious. So this increases the emissions and disasters, which affects the poor disproportionately. 1/3, this is extremely conservative, of solid waste is openly dumped or burnt. This is an average figure. And in low-income countries, waste management costs comprise 20% of municipal budgets on average. But this is only some poorer countries, low-income countries. And in many other countries, the budget is much higher than this. We will literally be living in waste if nothing is done. So what can we do? So we have environmental concerns because 30% of methane or 40% of methane or 30% of methane now is coming from the waste. And then on the extreme left, we have from the industries, we have CFCs and ozone depletion. We also have nitrogen oxide or nitrous oxide gases coming from that. And we have carbon dioxide, which is the biggest issue that is coming from the industries as well as from the factories and oil wells and so on. And then we have the result of all these nitrous gases and sulfur dioxide is the acid rain and acid deposition. And we also have another issue of photochemical smog, which is mainly from the cars on the highway, and which is a serious pollution concern in many countries now. And then when the nitrogen goes into the ocean and so on, we may end up with the algal bloom, which can cut the sun light to the lower level of the ocean, and then it will affect the overall biodiversity of the ocean too. So this diagram here actually gives you the sort of overall concerns, environmental concerns for air pollution, land pollution, and water pollution. So these are some of the serious issues that we will face if we don't manage the waste properly. And then again, another issue is that the illegal dump sites will allow the leachate, percolation of the leachate, and which will contaminate the groundwater pollution. And then it can also surface flow. I mean, in some countries, I've seen how the leachate actually overflows the landfill and flows into the nearby river and nearby lake, and thereby polluting the water sources seriously. And some innocent people do fishing in these ponds, not realizing that the water is already completely polluted, and the heavy metal will be absorbed by the fish and other organisms living in that water, but they are sort of not seriously aware of the consequences. And I saw the similar situation when we were doing the water sampling in the river, the second largest river in Malaysia, which was polluted with microplastics abundantly. And there are 6 species of fish that is thriving in that environment, and you have seen people fishing these fish and take home for eating. Well, of course, they don't understand what is microplastic and what are the consequences of this, but it is a reality. And then microplastic and nanoplastics, MPs and NPs, microplastics and nanoplastics affect ecosystems and the climate. So here, this diagram specifically is focusing on microplastics and nanoplastics. In case of any of you are not very sure where the microplastics come from, the 2 main sources of microplastic, one, of course, is from the cosmetic products, like, for example, the face wash and face soap and so on, which contains microplastic as it is, because it is added there to give the roughage. The second source of microplastic actually comes from the landfill and other dumping grounds, because they are broken down not by bacteria, it is broken down by the light, heat, and the acidity and so on. So they actually physically break into microplastics. So these are the 2 main sources of microplastics. And of course, anything below 5 mm, we classify it as microplastic, but if it goes below 1 mm, then we say is nanoplastic, and of course microplastic will eventually become nanoplastic, and they can stay in the atmosphere for a long period, like normal plastic. And the issue now is that microplastic has already been found in human blood, human organs like liver and lungs and heart and so on. It is also found in the central nervous system, the fluid. So it's there, it is everywhere. And in some microorganisms, it has been even proven that microplastics are so small that it enters the reproductive cells and is passed from one generation to the next generation. And it has already been proven in some of the very small microorganisms. So it is there. So the risk is very high, and we should appreciate why we are trying to reduce or control the waste that is going to the marine environment, specifically to reduce the microplastic and nanoplastic effects on human and environment. Now, what about the economic impact? Now, if you look at this, the blue color is a managed waste recovered value. So, of course, over the years, from 2020 to 2050, it is estimated that the amount of managed waste will increase gradually, and also the amount of material that is recycled or is converted to some useful products are increasing. That is the blue color on the top. And of course, we still have unmanaged waste, the red one, even now for 2024. You can see how bad it is for 2024, 1, 2, 3, 4, 5, the fifth diagram. And there's very little that is being managed properly, and compliant recycling costs is very little. So you can see it is hoped that the blue color, that is a managed waste, will increase as predicted in this diagram. And at the same time, the unmanaged waste will decrease over the years by 2050, so that we have more managed waste and more compliant recycling cost. Okay, so of course, the overall economic impact is increasing. This one we can't change, because the cost of separation and the cost of management will definitely increase as we go along with modern techniques. Like, for example, you can have a simple landfill for about 40 million, but if you were to establish a waste to energy plant, it may become 400 million. So these are some of the issues that we have to look at. So if you divert a little bit to the industrial waste, then we have different types of industrial waste, but most of the waste comes from the process itself, depending on what the industry is doing. If the industry is preparing, so for example, tire, the process of the tire is the process waste, but we also have non-process waste, for example, from the canteen, from the office, and so on. But important thing to understand is that not all industrial waste are hazardous. There are non-hazardous waste, especially plant materials, plant industry, like, for example, industries processing oil palm products. They are not hazardous, so that can be handled a little different way. Okay. The sources of the industrial waste, of course, I need not go through that detail, because I think you all know all the industries in India. And loss of resources, e-waste. The amount we are missing or losing at the moment is about 57.4 billion in materials lost. And the global value is about 17.4% recycled. So you see, there is tremendous opportunity for e-waste recycling. Of course, different countries will have different numbers. This is the average figure. And plastic, of course, at the moment, only 9% is recycled. 91% is wasted. And this is my concern, because this is the one that becomes eventually into plastics, microplastics and nanoplastics. So billions in recycled material are lost globally. Now, food waste, about 750 billion US dollar material is annually lost. This because of the unconsumed food or food that is semi-consumed. And we have a new trend in many developed countries and some of the modernly developing countries, where unconsumed food quantity is increasing. I mean, if you take the food and you eat it, it's okay, but there are people who take it and don't finish it, and that is called unconsumed food. Sometimes unconsumed food is completely unconsumed, because you buy a loaf of bread, and then after about 5-6 days, you realize that the fungus starts growing. That is also unconsumed food. So we have this 750 billion value lost, and this is about 1.3 billion tons. Now, energy waste, 6 billion is lost from non-recycling. And lastly, circular economy potential is 4.5 trillion annually by 2030. So globally, this is the missed opportunity. So when we talk about waste to wealth, this is what we are looking at. This is what we have missed all this while, and we should actually seriously consider how can we retrieve all this material. Now, this is just a general numbers, because it will vary again from one country to another. Landfill cost is about $30 to $100 per ton, and the global value is about 200 million per year, the global cost. Environmental cleanup is about 13 billion annually, particularly plastic waste. And health costs about 7 million premature deaths annually. And healthcare cost is also going up, and it's jumping leaps and bounds. And all the health insurance is going to increase it more than double within this year or next year. Tourism and property impact. Tourism loss is about 10 to 15%, and the property value drops 5 to 10% near landfills. So this is the cost of improper waste handling. Okay, I'm sure you're familiar with these various colored bins. So we have 6 types of bins in the developed countries, and in Germany they use more than 6, because, like, for example, for glass, They have one for clear glass, one for green glass, and one for brown glass, and so on. So you can see that for glass alone, there are 3-4 bins. Okay, so that is why in some countries, especially in Germany, I've seen not 6, I think more than 10 or 12 bins, and all are nicely labeled. And I was just looking for a few minutes, and people do bring and put it according to the label. Like especially those bringing the wine bottles, they are actually putting it in the right bins. White bottle, the white container, and then we have the brown bottle in the brown container, and so on. So that kind of sense of responsibility is very, very important for the sustainable waste management. Okay, so now another thing that we want to look at is for the waste is the composition. And you may be wondering, why are we looking at the waste composition? I think the waste composition determines the technology that you want to use. So without the waste composition, you cannot determine what technology you want to use and what is the optimum technology that is good for you. Like for example, in this case, this is global. Food waste is about 18 or 20%. And in countries like Japan and in Germany, they send this to anaerobic digestion to produce methane. Of course, some other countries may not have the facilities for anaerobic digestion, so they just do composting. And then, of course, we have paper, and then we have plastic, which is these two are the biggest issue. Paper, of course, paper recycling is not a big issue, but it will create tons and tons of wastewater, and it becomes expensive if there is no water for paper recycling. And plastic, of course, most of the developed countries consider paper the easiest way to dispose of paper is for burning. They send it to incineration, like in Japan and Korea, and also the many European countries. They just send it to waste to energy plant because what else can you do? You can't compost plastic, so that's what they do. And then, of course, e-waste about 2%. Now there's a tremendous potential for e-waste recycling, and many countries are very serious about e-waste recycling. So they're establishing some proper e-waste recycling facilities in many, many countries. Now, here we have the projection of global municipal solid waste generation per year for 2030, 2040, and 2050, which is quite similar to what I've already shown you earlier. This is taken from the Global Waste Management Outlook 2024. Now, in case you are not aware of this publication, GWMO, Global Waste Management Outlook, and I was one of the proofreaders for this edition for the second. This is the second one. It's called the GWMO 2, which just released. And here you'll find that this publication is freely available. You can either look in the UNEP website, or you look at the ISWA website, International Solid Waste Association. They are the two partners who actually produced this Global Waste Management Outlook. And there's lots and lots of information like this in that publication. It is available online, free of charge. And then the global direct costs of municipal solid waste management in 2050 under the 3 conditions. So you can see that over the period of time from 2020, and then we are trying to reduce the amount of material going to the dump site. But at the same time, the waste to energy is increasing in the 2050. Waste management as usual, or waste management under control is 2050. If you have the circular economy, then it's even better then, because in circular economy, the last column, obviously the recycling rate is almost double the 2020 value. So that is these are just projections. Projections given by the chapter editor for 2050, and what are the changes that's going to take place if we actually introduce circular economy, or we don't introduce it at all. Okay, waste management life cycle. This is just to give you, I think many of you may be familiar. So the waste inspection, Then we have the waste collection bins. Then we have the waste collection truck coming and then sending it to the recycling depository. I don't know how many countries actually have these recycling depository or material recycling facilities, MRF, and then it goes for recycling. Or the waste truck just sends it to a transfer station, which is simply a transfer station to do some minor sorting, and agricultural material can go for composting, and the remainder can go to the landfill, or there may be some material that still can go to the recycling facilities. So these are the various options we have in terms of okay.
பஸ்ல பாபு சாரு சும்மா எதுவுமே வாயே திறக்க மாட்டாங்க. ஆமா.
Hello? Hello, can you hear me now?
Hello?
Yes, sir. Okay, I don't know, somebody mute my mic.
Yes, sir. It is audible.
Okay, let me continue. Current situation and challenges. So I can summarize what we have been talking for the last 30 minutes. We can see on one side we have the rising waste quantity and the complexity. See, this is the problem. The waste quantity is increasing. The waste complexity is also increasing because we have more and more new waste coming into the system, particularly from the industrial area. Okay. The second thing we saw in a number of slides, the environmental issues, the improper disposal, which leads to the pollution in water, air, and quality. And government initiatives, programs under the, at least in the Malaysia's environment, like, hello?
Hi, sir. Someone annotate your slides, sir. Actually, it is scribbling your slide, so it is not visible clearly, sir. Can you see, sir, yourself?
Yeah, I can see it.
But we are seeing some
It's now moving. Okay, what I will do is I reshare.
Annotate. Annotation. Some others. Sorry, sir.
Never mind. I will share again. Can you see it now? Hello, can you see the slide now?
Yes, sir. Yes, sir. It is clear, sir. Now it is
Sir,
clear.
we can hear you. Please go ahead.
Okay, I will go to
Yes,
the
sir.
about. Okay, you can see this. Can I continue?
Yes. So 1 minute. I request participant, please don't write. Professor is delivering a lecture. Please respect it. Sir, you please go ahead, sir.
Yeah, many people want to say good evening, good evening, good evening.
No, sir. You please go ahead, sir.
Okay, now let's look at the current situation and challenges. And I already talked about rising waste and environmental issues and government initiatives. Like in Malaysia also, we have many initiatives. After more than 20 years, the Malaysian government actually changed the policy from no waste to energy. Now they say yes to waste to energy projects, and many waste to energy projects are being developed now. The next 3-4 years, we will see a number of waste to energy projects being in the pipeline. Okay, so we are trying to establish what is called a sustainable waste management. This is what we want to do so that we can achieve the proper usage of the waste material to its full form. Unmanaged waste causes pollution. It contributes about 20% of global methane emissions, particularly from landfills. Now, of course, everybody knows that methane is one of the biggest culprit for global warming, and it's coming from landfill. 13% of global municipal waste is currently recycled. The leading countries recycle over 60%. And I know some countries, even in India, your recycling for plastic is very, very high. But unfortunately, you can't say the same thing for organic materials. So recycling 1 ton of paper, we could save about 17 trees and 7,000 gallons of wastewater that will be coming out. Landfills account for about 5% of global greenhouse gas emissions. So this is the overall greenhouse gas emission, including carbon dioxide and so on. So we diverting the organic waste through composting, we may be able to reduce 25 to 30% of the municipal waste. As I mentioned earlier, most developing countries, at least 50% of the municipal waste is organic waste, and we can reduce that by almost 25 to 30%. The recycling industry is valued at over $200 billion US, and it employs 20 million people globally. And this is what's happening in developed countries. And even in Asia, of course, Taiwan is one of the champions in recycling industry. So this is the situation we are looking at. So the environmental and economic impact, one more time, we can implementing the waste to earth initiatives. We can significantly reduce the landfill use, and we have potential to divert 60 to 70% of the waste from landfills. So this is one of the important things when we actually use the waste and produce some useful material. This process can lower the greenhouse gas emissions by about 1,100 to 3,000 million tons of CO2 equivalent annually to improve waste management. The global market for biomass and waste-derived products is expected to grow by about 10 to 15% annually, creating significant economic opportunities for the low-income people. And the transition to waste-to-wealth strategies could generate about 300 billion new economic activity globally by 2030. That's not very far from now, it's in 6 years. So you can see there is tremendous opportunity for using the materials in the proper way, so that we can actually implement some kind of waste usage or waste to wealth manufacturing. So this diagram here, the concept of 3 Rs in a sound material society, sort of summarizes what are the things that can be done from the waste. So we have natural resources over here. And then this is the production. This is where the manufacturing and distribution is taking place. And then from here, we go to the consumption, that is the public. And then we discard it. And then when we discard it, it goes to treatment, final disposal. But I think that is not what we want. So what we want in the production itself, we want to reduce the generation of waste and byproducts. So of course, many companies have actually started the modification of the product design so that the amount of waste coming is reduced. So here, the production stage itself, we can modify the pattern or the design of the product to reduce waste. And then, of course, we can reuse things that repeatedly that can be used again and again. And here we have to teach the public on the need for source separation of material, because if material is separated properly at source, then half the battle is won. So the remaining half is easier. And then, of course, we have recycling, then the energy recovery. Here, this is the new thing that people are looking at, like incineration, pyrolysis, and biogas generation, or even hydrogen production, a lot of things here. And then material recycling. So we have many options to implement to give value to the waste. Okay. And then we have the waste pathway for 2035. So I'll go a little slow. So we have in 2022, we have consultation of curbside sterilization. This whole diagram is for New Zealand waste strategy, and which can be applied by any other country that intends to actually implement waste reduction and waste utilization. So this is mainly the pathway targets waste emission to support and shift to circular economy from linear economy, and to reduce our biogenic methane emissions. That is one of the targets. Strategic changes will support emission reductions and efforts to reduce waste emissions must focus on organic waste. Now here they started the consultation on curbside sterilization, the new waste strategy and the waste policy, and waste infrastructure was planned, and then the landfill gas capture feasibility was considered. And then in 23, they increased the investment in resource recovery, and then they also looked at organic waste prevention program. So the organic waste was prevented from going to the landfill. So they were looking at other options. So in 24, the new waste legislation was enacted by the New Zealand government and a natural waste reporting program. So this one is like monitoring the waste flow from the source to the end. More council curbside organics collection. So now they specifically collect the organics on a certain day so that it doesn't mix with the other material, and more new organic recovery facility were established. And then for next year, their new regulation will come in to reduce the emissions from waste. A proposed national waste licensing scheme introduced, and all municipal landfill required to capture gas by the end of 2026. So no landfill will be dump site. It will be all sanitary landfill with proper liner material and proper gas collection piping systems by 25. And then by 2030, possible organic waste landfill limits or bans by 2030. So they probably ban the landfills for organic material. And by 2035, 40% reduction in biogenic methane can be achieved. Now, this is a case study, an example for New Zealand, which can be actually applied to any other countries in a proper systematic way to eventually close the landfills and to increase the usage for the organic material for energy capture and so on. Now, from now onwards, I'm going to part 2. What are the options we have to generate energy or to find some useful worthiness for the waste? Now, number one, waste to energy, very popular nowadays, waste to energy. And I'm not going to describe how this incineration functions. When you look at it, you can see that the waste goes in on the left, and then it is taken to the furnace where the combustion takes place, and you can see the flame. And then, of course, the energy is utilized to produce steam, and from the steam, we can produce electricity. That is what is happening in many developed countries. And nowadays, nobody wants an incineration plant. They don't even want to call it an incineration plant. They want to call it waste energy plant. Because no plant, even in Malaysia, all the new plants that we are building is completely waste to energy with a capacity of 1,000 tons a day to about 3,000 tons a day. That's what we are doing in Malaysia. Of course, the real big ones are in China. They have one in Shanghai, which can burn 5,000 tons a day. And I think they're building one more, which can take in 8,000 tons a day. These are all in China. And China is going to overtake Japan very soon in the number of waste to energy plants. Japan had about 1,400 plants, and initially they were not waste to energy, they were incineration plants. So Japan converted many of these into waste to energy. But China is building all waste to energy plants in a very fast phase, and eventually, maybe by next year, they will be the number one in terms of the number of waste to energy plants in the world. So waste is converted to electricity or heat. In some countries, they actually use the heat directly, especially during winter, to heat up the house because no, they don't want to go to the next level, because every change in the energy system, you lose 20%. So they don't want to use the steam. So they use the heat directly to heat up houses during winter. Okay, so in other places, you can use for gasification or pyrolysis. Now, for example, Singapore has got 5 waste to energy plants. Almost 100% of their waste is actually incinerated, and they produce the electricity. And the ash is thrown into the Semakau landfill, which is down south of Singapore, where an island was created for the purpose of discarding the fly ash and bottom ash. And that island has now become a tourist attraction. That's because the original cells 1, 2, 3, and 4, where the secondary forest has come, and the secondary forest is attracting so much birds and so on. and it has become a nice place for holiday, and people go at night specifically to look at the stars, because there are no big trees there, so they can do stargazing also from there. So this is one, waste to energy. One of the relatively new option we have is to waste to hydrogen. There are more than one way to produce hydrogen. So we have organic and plastic waste is used to produce hydrogen. Maybe we can use pyrolysis, which means for the temperature is controlled. You don't have to put a high temperature like incineration, where it's about 1000 degrees centigrade. Pyrolysis can be done at even 300 to 500 degrees centigrade, or we can do gasification or anaerobic digestion, which will be a little bit more cheaper. In Osaka, for example, in Japan, waste is converted into hydrogen to fuel buses and other hydrogen-powered vehicles. They also have in Tokyo one anaerobic digester in Tokyo for 100 tons of organic material, where the food waste is used to produce biogas by anaerobic digestion. And the biogas is given to the lorries that bring in the food waste free of charge. So that is one option on attraction. So 60 to 80 kilogram of hydrogen can be produced from 1 ton of waste, contributing to about 80% of the global energy needs by 2050. So as I say, producing hydrogen is the in thing now. People are actually trying to do various methods. One of the most recent method I saw in China, they're using electrolysis of water to produce hydrogen, oxygen. Of course, all these methods needs to be refined. Some may not be working. Some may have its own risks. They are hoping to use hydrogen car soon. So this is upcoming technology people are hoping to capitalize on. We can also produce chemicals and enzymes, particularly from the food waste. Supercritical CO2 extraction we can use, and we can use also thermochemical conversion. For example, biological and chemical processes extract valuable chemicals and enzymes from waste, including food waste, particularly biomass. Novozymes extracts 0.3 tons of enzymes per ton of food waste used in food processing, biofuels and detergents. Captures up to 50% of food waste chemical potential, reducing raw material reliance and diverting waste from landfill. So instead of dumping it in the landfill, we can consider this also if we have the technology for chemical extraction, supercritical CO2 extraction. This is not a relatively new technology like in the case of hydrogen. It is quite used. Anaerobic digestion, of course, is very, very popular. One of the reasons, of course, is relatively more economical. I will not use the word cheaper. There's nothing cheap in waste management. Only thing is that which method is more expensive and who can afford it. Anaerobic digestion, or we are talking about biological treatment. So you can have anaerobic digestion, where the organic waste is broken down in anaerobic conditions, producing biogas for energy and digestate for fertilizer. So this is a common practice nowadays. After anaerobic digestion, the digestate that comes out eventually is exposed to the air for a couple of weeks, and it becomes a perfect fertilizer for agriculture. So nothing is actually wasted. And bioenergy park processes about 40,000 tons a year, generating about 9.8 million cubic meters of biogas. And this is just one example for you. And then we have 1 ton of waste generates about 100 to 150 cubic meters of biogas, producing about 300 to 600 kilowatt hour of electricity. So if you want to go to the next level, so you can see that nowadays they have large animal farms for various large animals like dairy or swine, and also the wastewater biosolids, and then food waste and organic fractions. So they undergo anaerobic digestion without oxygen, and then you can use the biogas directly for the fuel, or you can use it for electricity generation, or for heat generation, vehicle fuel, or renewable natural gas. And digestate, as I said, digestate, usually we expose it to the air, and we can even call it compost after this stage, is used for horticulture products, organic fertilizer, animal bedding, and other products, and even for mushroom growing, it can be used for various options. Of course, this is centuries older process, waste composting, and of course, I know India has been using this for maybe 3,000 years ago. Unfortunately, this has to be capitalized on a large scale to see the sustainability, because if it's small scale, you don't see the benefits to the environment. So this is biologically composed, and of course, some people may even say that, oh, we can induce composting using microbes and so on. It may not make that different. It's a matter of a few more days, and you might as well let nature do the job, and you don't have to use effective microbes. And that's my opinion, but you may not agree. So the city of San Francisco processes about 600 tons of organic waste daily, converting it into high-quality compost for agricultural applications. So each ton of organic waste produces about 300 to 500 kilograms of compost. Now, this is normally the case, because usually if your composting plant is efficient, you'll get about 40%. You will never get 100% compost. If you put in 1 ton, you won't get 1 ton of compost. You only get less than half a ton. So this is what I'm saying, that 1 ton of organic material, you get about 300 to 500 kilograms of compost. And this will be excellent material, provided you have actually used other additives, like, for example, organic plant material mixed with the animal waste, or even biosolids from the wastewater treatment plant. Then your compost quality will go up, and then it will be useful for the environment as an excellent fertilizer. Now I move on to the e-waste. Of course, the e-waste, we can't use many of this material. What we need is to separate the e-waste into various components first, the plastic, the circuit boards, metal parts, and so on. And then, of course, the various technologies are used for the extraction of the metal. Like, for example, we have in Malaysia, we have there are only 3 large e-waste recycling plants in Malaysia, full recycling. These are the 3 full recycling. We have more than 100 who claim to be e-waste recyclers, but they are not recycling. They actually do the dismantling. After dismantling, they actually supply to the various people, the metal recycler, and then the circuit board to the e-waste people. But we have 3 large full recycling facilities in Malaysia, and they use technologies like hydrometallurgy, pyrometallurgy, and biometallurgy to separate the various components, like, for example, gold, silver, platinum, and so on. And so, for example, the Umicore, a Belgian company, processes about 350,000 tons per year of e-waste, recovering 96 tons of gold, 350 tons of silver, and 50 tons of palladium annually. So these are just one example. Each ton of e-waste contains up to about 100 grams of gold and 300 grams of silver. And these are the 2 metals that actually have got good value, providing a valuable secondary resource while reducing environmental pollution from discarded electronics. And I think many of you may know that in many developing countries, the e-waste recycling is so rudimentary, where people actually do it in open air, where they put the e-waste in the quali and then they put in the acid and melt it under flame. They actually breathe the acid fumes as well as they release acid fumes to the environment, which is totally unacceptable. We can't accept such an activity, and also, but this is what's happening in many poor countries. There are many initiatives that has been taken over the global area, like solid waste emissions. If unaddressed, we could reach 2.6 billion tons of CO2 equivalent by 2050, and we have to seriously consider how we can reduce this emission and to reduce the global warming. Informal recycling, as I mentioned earlier, of course, they play a very important role in increasing the waste recycling recycling capacity and decreasing the waste capacity, and it's also elevates poverty for many of these sections. And there are over 50 million informal waste because face unsafe working conditions, lack social support. Now, the problem, as I said earlier, some countries like Thailand has already started to formalize the informal recyclers. So they have given them proper housing facilities, and this is a recycling colony. And within the recycling colony, they still continue doing the recycling, but they actually sell it to the recycling zero-budget shop, where they can buy anything by giving the recycling material to that particular shop, and then the recycling items are collected and sold to a bigger recycler, one party, who fixes the price on a daily basis, and the shop belongs to the recyclers. So there's no issue of who is owning the shop. The shop belongs to the recyclers, and the whole community is benefiting from this exercise of formalizing the recycling. And water waste to recommendations. This is another publication that you can put your hands on. Water waste by the World Bank. It's also available free in the World Bank website. So there are also strategies including formalizing the role of waste pickers. So as I said, they play a very important role. We shouldn't eliminate them. We should formalize them and capitalize on the opportunities. So this diagram actually gives a summary of what we can do with biomass. So we can use it for combustion. Like for example, in the oil palm industry, we actually burn the seeds. After the kernel oil is extracted, the shells are combusted and they used to produce energy. Gasification, liquefaction or carbonization, esterification, hydrogenation, and fermentation. So all these technologies are already being practiced, and they are already giving benefits like heat or electricity or VDF and bioethanol and so on and so on. So the opportunities are tremendous. Okay. This is an example. Bilan's biorefinery process is a case study where they're using biorefinery is what is called an integrated system. So if you look very carefully, nothing is going out of the system. Everything is within the system. Okay, so they have a wastewater treatment plant. The clean water improves the quality for agriculture. Then we have organic waste from households taken for the energy production. The manure from the cow and so on is also taken for the energy factory. And the biogas is used for electricity or heat generation and so on. So this is comprehensive, and this is how it should be, ideally. Another example, so this is specific for biomass conversion. You can have enzymatic hydrolysis, fermentation, and then fermentation, or you can also send it for liquid biofuel, biochemicals. So we have the anaerobic digesters, which can produce methane and CO2. Aerobic digestion, of course, this is for treatment of the wastewater. Then, so, okay, these are the innovative waste management solutions. We can have smart waste collection. So nowadays they use IoT sensors. We can actually measure the quantity of waste that goes into a bin. And so the bin itself has got the chip, which all your details. The moment the lorry carries your bin, it records the name of the person, the address, and the quantity of waste. At the end of the year, you get a bill based on the amount of waste you throw. The more you throw, you pay more. So this is being practiced in some developed countries. And then mobile apps provide recycling options and collection schedules. Advanced recycling technologies are used for automated sorting system. Nowadays, they use artificial intelligence to sort the materials. So this is already being used in some developed countries already. They can separate the waste according to the design that set. Chemical recycling, then also waste energy technologies, which we already discussed quite a lot, like anaerobic digestion, gasification, and so on, and composting, which is a biological treatment. So, trash to treasure. We have so much that we can do to generate or make the material what we call waste is not actually waste. It is a resource. It all depends on exactly what we want to do with the material. And the technology is already available. Do we have the funding? That's a different question. And do we have the regulations? And do we have the policy? Do we have politicians who are serious about implementation? Do we have enforcement, proper facilities, and so on? So there are many, many problems in many different countries for the lack of utilization of these materials. Okay, so this is the thermochemical conversion and biochemical conversion process, which actually we already discussed this, but this is a summary of the various processes that we discussed. One important thing that I want to say before I end my lecture, industrial symbiosis. In many countries, this is the fashion. We have examples from Japan, Korea, Australia, New Zealand, Germany, and so on, of industrial symbiosis. Basically, this is, in many countries, we have industrial parks. Even Malaysia, we have industrial parks. But industrial parks, each industry operates like a silo. They actually don't know what the neighbor is doing. But in the industrial symbiosis, everybody knows everybody else. So if I actually bring in food waste in a plastic, and then after shredding, I process the food waste. The plastic is separated, and I pack it and sell it to my neighbor who is a plastic recycler. That is industrial symbiosis. So in Japan, for example, there is a recycling industry area. The whole area is recycling. So one guy is doing food waste, one guy is doing plastic, another guy is doing tire recycling, another guy is actually doing battery recycling. And each one actually contributes the raw materials to another plant, which is relevant. So nothing goes out of this as waste in this industrial symbiosis. This is the most important thing that seriously. And Malaysia recently announced first time that they want to establish a very large industrial symbiosis in the northern state of Penang. And it is not a government initiative. It is a private company that is spending, I don't know, 500 or 600 million. That's about 100 million US dollar. They're spending. The private company is going to establish an industrial symbiosis complex in Penang. Okay, so this is the tool for the biosis and industrial symbiosis tool. And lastly, the circular economy. We've been talking about this many times throughout today's lecture. So to give you an overview, so globally, the circular economy could reduce about 45% of greenhouse gas emissions from industrial sectors by 2050 if fully developed. So at least in Malaysia, the government aims to achieve 40% recycling rate by 2025 as part of its efforts to transition to circular economy. Now, the government is quite serious about this. So at the moment, we have achieved more than 30%. So by next year, we should hit the target because the government is very serious and they committed this value to the United Nations. Okay. Waste as a resource in 3R. This is another example from IKEA. Hello. You can't see my again?
Yeah, please go ahead, sir.
You can? Okay, this is the theory part, the circular economy concept. Okay, from waste to worth. We have seen how innovative waste management can reclaim up to 90% of the discarded materials, turning waste into resources. By focusing on recycling, reusing, and composting, and we can reduce the raw material usage by 50%. So, yeah, these are some of my books. My latest book is the Healthcare Waste Management and COVID. So, all in there are 22, but I'm showing you a few here. And this is my team of PhD students in the Sunway University. I'm not showing you my master students. And that will be all for tonight. Thank you very much.
Thank you, Professor. It was a very interesting presentation. I request participant, if you have any queries you want to discuss, please, you can drop your message in chat box or you can interact directly with professor. And also I request participant, please check your chat box. I have sent you the attendance list also, attendance link. Please fill it. No questions? Please unmute and you can ask the questions if you have any, if you want to interact with professor.
Everybody is saying thank you, sir. Nobody is asking any questions.
I think that's really nice. If you don't have questions, then we will end this session. Is it okay? I request all participants, could you please answer?
Hello, sir. Good evening, sir.
Yeah, please.
Sir, I am Professor Edil Maran from Chennai Institute of Technology.
Okay.
Sir, it is a really very good presentation, sir. It is a eye-opening presentation for us. So, really thank you for our professor. Sir, one suggestion, sir. Is it possible to give some solution to uh, this waste management to avoid pollution in Delhi, sir, nearby areas?
Waste management, eh?
S-
Nearby,
Sir, could
what
you,
if- Hello?
sir,
Can
could
you
you
be
get
louder, Professor, please?
yes, sir. Yes, sir. Yes,
Yeah,
sir.
please.
So, is it possible to avoid this air pollution in Delhi by waste management around the Delhi areas? I am not telling about the Delhi, nearby areas, sir.
Around Delhi?
Yes, sir. Surrounding, sir.
Yeah,
Because of
but
by properly using the waste
I
management.
only yesterday I came back from Vishakhapatnam, Vishak. Only yesterday I came back and I was looking at the Indian news most of the time. I know how bad the air pollution is in Delhi and in Mumbai. But I think these are local issues, I won't say that one of the contribution is the landfill. Everybody says that the landfill in New Delhi is not a sanitary landfill. So in Malaysia, we had similar issues. What we did was we closed the landfill and we completely covered it up with half a meter of soil and put in materials plant to grow. And we established the landfill away from about 40 kilometers away from Kuala Lumpur, away from the city. And that is a sanitary landfill, which is producing about 8 megawatt of electricity now. So we don't have any problem. Before that, it was in within the city limit. But we don't have any landfills within the city limit. And this is one of the things that we did. There's one question here, in what way we can reduce greenhouse gases? I think this is what we have been talking the whole day. Try to reduce the organic fraction in the waste. That is the main culprit, the organic fraction. And we have another question here, how circular economy can be implemented in PET bottle concepts. So I think it is already been implemented. PET bottle recycling is one of the standard recycling practice that is being used now. I'm not saying that you should send all the bottles to the waste to energy plant. It can be recycled and reused for other non-consumable products. I don't see any other questions. There are only two I can see in the chat box. Okay, Prof. Naveen, any more questions?
Okay, sir. Thank you. Okay. Thank you, participant. We will have 10 minutes break. Then again, we will be joining.
Oh, okay.
Okay, Professor. Thanks a lot.
Thank you very much. Thank you very much.
Thank you, sir.